Thank you. So, hello, everyone. Good afternoon or good morning, depending on which coast you're on or somewhere in between. I'm Rodney Sobin. I'm a senior fellow at NASEO, the National Association of State Energy Officials. And I am very happy to welcome you to today's NASEO State Industrial Working Group webinar with the Renewable Thermal Collaborative. Today, they will discuss their renewable thermal vision and provide an analysis of industrial electrification in U.S. states, and discuss policy and some tools that RTC has put together. We're very glad to be joined by Blaine Collison of the Renewable Thermal Collaborative, Daniel Riley of World Wildlife Fund, Ruth Cheknoff of David Gardner and Associates, and Chris Kardish of the Center for Climate and Energy Solutions, affectionately known as C2ES. And before we get to the main points, I do want to thank my colleague Jasmine Shia for her support of this webinar. And Jasmine, if you can go to the next slide, I would like to go over a few logistic items. Please mute when not speaking. We do not have a Q&A box, but we do have the chat function, so feel free to offer questions via chat. I think if we have time at the end, we'll also maybe have a chance for verbal questions, but use the chat box. As mentioned, this will be recorded and posted on the working group site for listening at your pleasure. Next slide, please. I also want to take a few moments to go over the working group, provide an overview. Our purpose is to help the state energy offices and others within states to identify, develop, and enhance resources to advance clean manufacturing and clean industry. We're also working, and this is quite an objective of ours, to enhance cooperation and coordination across various technical and business assistance programs. And this includes DOE programs, as well as Energy Star, NIST MEP, state pollution prevention, small business assistance, to enhance the cooperation and coordination of those sorts of services. We're working with the states to support their economic development and productivity objectives, their environmental objectives, and to support energy reliability and resilience. The working group is very interested both in existing industries as well as in new technologies and industries. As you may know, there's a lot of flurry of interest in new green technologies for solar and EVs and so forth, which are all certainly of interest, but we are also very concerned about and very interested in supporting existing industries, whether it's dairy or steel or chemicals or whatever. So we're very glad to be able to support that. And we are very thankful for the Department of Energy and its Industrial Efficiency and Decarbonization Office for their generous support of the working group in our initiative. Next, please. We have 17 states currently participating in the working group, and we welcome other states and territories to join. Our members are not only from the state energy offices, but we also have other state and public and quasi-public officials. We're very fortunate to have had the Connecticut's Chief Manufacturing Officer participate in the working group, and PennTAP, the Pennsylvania Technical Assistance Program, and the Intermountain IAC, the Industrial Assessment Center in Utah. And we welcome not only the state energy offices, but other entities that are working in the states to promote clean manufacturing. Next, please. So we provide web resources and email updates on these technical and business assistance programs, on funding opportunity, including the IRA and bill provisions, updates on reports, studies, events. I will not read the list there, but among the recent items that we posted include some of the things that you will hear about in a few minutes from our friends at the Renewable Thermal Collaborative. We're very excited to note that the Department of Energy will now have grants to support small, medium-sized manufacturers to implement Industrial Assessment Center and CHP TAP recommendations. In fact, that was just a webinar that finished moments ago. And we've also posted guidance on the Advanced Energy Project Credit Program, 48C tax credits. So there are quite a few things that we try to keep abreast of and to inform members of the working group and folks in general. Next slide, please. So we do run forums and webinars. This is a public webinar that you're welcome to. We also have state-only forums. Past ones have included one where we focused on the Connecticut's manufacturing ecosystem, as well as having DOE presentations on the Advanced Energy Manufacturing Grant Program and the Industrial Demonstrations Program. Just last month, we had a focus on industrial assessment centers and some related DOE-supported technical assistance. And we're very pleased to note that next month we will have a forum featuring the NIST Manufacturing Extension Partnership and EPA's Energy Star Industrial Program. And you'll see there some candidate future topics, including IRA tax credits, DOE's industrial decarbonization roadmap and the DOE heat shot, and some other laws, including CHIPS and Science Act provisions which are pertinent to manufacturing. We also hope to have and plan to have state focus in each of our forums. And also we will be working to identify state case studies, experiences, and lessons. And let me then hand this over to Blaine Collison to start off the main part of the program.
Thank you, Rodney. Really appreciate the chance to come talk with folks today. They're looking at the objectives bullets there for the industrial working group. I kept nodding in my head. Yeah, boy, that, yes. So this is, there's a lot of alignment here, and I hope that what we'll lay out, sharing the things that we're working on will be interesting and will prompt some thoughts and discussion. I suspect that we're all trying to go generally the same place, and not a moment to spare. So next slide, please. Look, what I'm going to do here is just introduce the RTC and explain who and what we are, and then I'll get out of the way for my colleagues to dive into some of the really interesting pieces of work that we have going. But this is the RTC. We are a global buyer-led coalition focused on decarbonizing thermal energy with renewables. Right? Our work is centered around end users. Most of, and I'll share that group in just a second. Most of our end users, our members, are industrials. Most of them are, in fact, global industrials. We have 3 U.S. cities that are members, the cities of Philadelphia, Pittsburgh, and Cincinnati. The state of Wisconsin is a member. Kaiser Permanente and the University of California system are members, right? So we're looking at thermal energy, not just from an industrial process set of applications perspective, but that's a big chunk of our work, but also thinking about thermal energy for the heating and cooling of buildings, right? We focus our work really into 3 broad chunks, and there's sort of a fourth, right? Technology. We're not an R&D shop, but one of the issues that our members have come to us with is, listen, we don't know this set of decarbonization technologies. Yeah, we need to get smart about this. Who can we talk to? How do we think about these technologies? Green hydrogen, thermal storage. How do we think about electrification and RNG and biomass? I think I'm missing one. It'll come to me. Certainly green hydrogen. Oh, boy, Dan, I almost had it, but not quite. RTC charades, everyone, welcome. Solar thermal, thank you, sir. One I really ought to know best. So thinking about technologies from a how do we do this perspective, right? thinking about market development, greenhouse gas accounting rules, third-party financing models, right, and innovation, and in fact, the connections between end users that have hundreds, if not thousands, of global facilities and production capacity that needs decarbonization, and innovative solutions providers, technology developers, right? And then, of course, policy. Our policy focus has so far been mostly U.S. federal, but the states are a hugely important next frontier, and Chris will talk probably a little bit more about some of our thinking there. So all of this work is designed to look at the barriers, figure out and accelerate the solutions, and get on with implementing projects and policies. The RTC is an initiative that is, excuse me, co-created and managed by C2ES, DGA, where Ruth and I work, and WWF. I serve as the executive director. As we start to go through this, I suspect that a lot of you will think, boy, this sounds an awful lot like some of the renewable electricity work that we've seen that's been really interesting these last 20 years. And that's not an accident. Next slide, please, as we go to the members. You know, the RTC exists because, what, 6-7 years ago, half a dozen of these companies, all of whom had been active in and remain active in the voluntary renewable electricity space, which is where my own background lies. Some of them have been clients. So it came to the co-founders and said, listen, we've all got public greenhouse gas reduction goals, net science-based targets, net zero, right, whatever it is. And we've been working on the electricity side. We're not done, but we think we've got line of sight to being done, right? We've innovated, we've collaborated, we've collectively created offsite PPAs and virtual PPAs, and there's third-party capital coming to these markets, and there's a compliance market in the States, and right, there's stuff here. But they said, we all make stuff, right? Or our residents are collectively, you know, heating tens of thousands of buildings, and we don't know how to solve for fossil gas, right? We have public commitments, we're doing the math. We cannot hit our goals if we don't figure out how to solve for the gas side. So can we start to leverage some of these same plays and approaches that have been so effective on the electricity side here now on the thermal side? And we thought that was a fantastic idea, and here we are, right? This is our current set of members. My very most favorite thing about this slide is that it is sometimes very challenging to keep up to date. If we were doing this 2 weeks from now, we would announce probably 2 new members, both from heavy industry, which is really exciting. But you can see there's a global spread, there's a sector spread, right? We've got everything from pharma and food and beverage up to building materials, right, and chemicals, and again, states and cities. So this is the growing group of companies working these problems and collaborating here. And then next slide, please. And this is where I'll wrap up. These are our sponsors. This is the group of stakeholders that's come to the RTC saying, listen, we've got part of the solution equation. So looking across this group, there are green hydrogen developers and innovative solar thermal developers, thermal energy storage providers, RNG developers. There are third-party financiers. There are biomass companies. There's a reinsurance company. There are utilities. There are project developers and NGOs. It's been really interesting, and this is a huge part of our work, to see the companies coming to the space saying, listen, we've got a goal. We've got a number of our members have goals that are due right soon, in the next 5-10 years. We got to go, and we need partners, right? We're trying to master multiple technologies across multiple facilities and multiple heat requirements, and figure out what the decarbonization stack is here. How do we execute this? Who do we partner with? How do we learn about this stuff? How do we find opportunities and go and accelerate and scale and get to net zero in a compelling way? And that's that's really the fundamental thing that the RTC is working on. How do we get to net zero, particularly in the industrial sector, but also the building sector, as fast as possible, and innovate and finance it and go and make it happen. So that's the intro to the RTC. And I think now turn over to my colleague Dan Riley, who will share some of the really interesting analysis that we've done.
Great, thanks so much, Blaine. And welcome everyone. My name is, or thanks for having me, and welcome. My name is Dan Riley, and I'm director on WWF's Climate Energy team. Today, we want to talk to you about some analysis that we've done that we call the Renewable Thermal Vision Report. And this was some work that basically we had to do because we knew, of course, that there were going to be market policy, technology barriers out there to preventing companies from decarbonizing in the thermal space. But we also knew that we had members coming to us from very different sectors in the industrial and manufacturing economy, but they were saying to us, well, which of these technologies that Blaine mentioned, which should we be using, and where should we be using those technologies, and when should we be using them, and in what sequence? And we said, it's a good question. Let's go talk to the experts and look it up. Let's go find the report on that, and we can come back and tell you. And what we found out is that that work really didn't exist yet for Scope 1. And in fact, to a large extent, here in the US, there really wasn't even a clear understanding of what the problem was. Where were the emissions for Scope 1 in industry in the US, and for what sectors, and at what heat, and for what industrial processes? And so it was hard enough to get answers to these questions, for the company level. And for us at the RTC, it was hard to understand what our strategy should be and how we should start thinking about this at the aggregated level, because a lot of this data was out there. Of course, EPA had data, and DOE and EIA, but it was all buried in spreadsheets and in MEC reports. So we partnered with BCG to try to pull all this together in a way that was sort of absorbable and understandable, and so that we could at least start a conversation about what should some of the pathways forward be, and how can we start to think about this in a way that we could start to understand how these different technologies would serve different industrial sectors, subsectors over time, how they would start to be sequenced, and what was going to be the cost-effective paths forward, and how is this going to work for different parts of industry. And so I'm going to spend a few minutes sharing some of those insights with you today. And I'll drop the link here into the chat. This is the report. It's dense. It's about 200 plus slides. There's a 40 slide executive summary. Then we have 6 different sector packs, we call them, each about 30 or 40 slides that dig into the different sectors that I'll talk about. And there's 8 different technology packs. So it's really, there's slides. There's not a lot of reading. There's a lot of data in there, and graphs and charts for the geeks that I'm sure would come to a NASEO meeting with this title. So please go check it out. But today I'll kind of take you through some of the headline findings, and then give you a hint of what some of the insights are there, and how that you can start to see how some of those shake out at the state level. So next slide. Sorry, and again. So just a quick word on some of the methodology. So again, we partnered with BCG on this. First, we had to, again, assess the thermal emissions. So some of the sources we used, the EIA Outlook. A lot of this information came from the flight database. We used the 2018 numbers for a variety of reasons, mostly comparability for some of the energy cost, some of the energy demand numbers, but that's a different story. Technology reviews of what was available, fuel supply availability as well went into this. Then we had to look at also what were going to be the cost and availability to actually deploy the different technologies. And then we had created a model to how those different technologies at those costs would be taken up across various sectors. So that was sort of the 5-step process that we used, obviously across a variety of different sources. Next slide. So what's within scope for the study? In terms of the emission type, we're really looking at on-site scope 1. So we're not looking at scope 2, electricity. We're not looking at process, like industrial process related emissions. We're looking at the thermal emissions, and we're not looking at life cycle. In terms of the different sort of decarbonization technology pillars, energy efficiency, hugely important, but we left it out just to simplify the modeling in terms of the uptake. So obviously you can always consider the effects of energy efficiency as you think about how strategy could be enhanced when you consider the results or what we show you. But we did include CCS, of course, energy storage, electrification as a strategy for scope 1, and then low carbon fuels and energy sources. Next slide. So why are we doing this, and what is this important? I think we all know this. We're seeing industry here is 24% total emissions in the US, with half of that really coming from thermal. And as you can see, there's progress, particularly in power generation expected. We know there's a lot of transportation is growing rapidly, and we're seeing a lot of work being done, but really not a lot of progress being done in industry. You can see the uptick there. And in fact, in some global projections have industry by 2030 really projected to be the #1 source of emissions in these sector cuts. If you include the use of electricity by industry, it very quickly goes to #1 globally and in the United States as well. So it's a critical part of the equation. And of course, why, as Blaine mentioned, why the RTC is here. Next slide. So what did we find? The first thing we had to do was sort of understand a little bit better the problem. So we took a look in the US, where are the industrial thermal emissions coming from? And what we found is that the top 6 sectors are refineries, chemicals, iron and steel, food, paper, and cement. And then there's a long tail, and then an even longer tail sort of clustered together, all out of manufacturing there at the end. Paper, that box of 111, that's the unreported biogenic emissions. So those are typically accounted for as carbon neutral emissions, but because they're biogenic. But it's a huge amount of emissions within that sector. So in the report, we do offer some further insights into that in terms of ways of reducing that emissions, because of course those are emissions that still go into the atmosphere. And then of course there are some strategies for reducing those beyond just accounting as carbon neutral strategies. One of the things that we looked for one of the ideas that we had as we were approaching this is that we knew when folks think about industrial thermal emissions, something that quickly comes to mind is the iron and steel sector. When you think of the molten orange and red metal being rolled out, and we think of the very high heat that goes into that. In fact, that is a key source of emissions in the sector. And we know that that's high heat, hard to abate, and we've heard that a long time. We also talked to many of our members, and we knew that there's a lot of other industrial processes that exist in the sector. Like, for example, in the food sector, like pasteurization, and for example, in the paper sector. And we knew that that was going on at much lower heat processes, that it takes lower heat to do those processes. And our thought was that even though that was a lower carbon intensity process, we believed that there were much more of that process going on in the United States. So in the aggregate, what was the effect that those processes were having on total emissions versus the much more intense processes, say in iron and steel, that were happening less frequently? And so we wanted to sort of look at the total heat across the industrial sector to see how that affected emissions. So one of the things we looked at was how heat played out. So we wanted to see where were the emissions by sector, and then where were the emissions by heat, high, medium, and low. So next slide, please. And what we found was that there was a real spread in that a lot of the industrial emissions were coming from, as we kind of suspected, lower temperature industrial processes, seen here in the blue, and really in the medium range below 500 degrees Celsius, seen here in the orange. So you can see that truly iron and steel, there is a lot of that high temperature, almost 2/3 in the iron and steel, but you can see across a lot of these other sectors, a lot of the industrial emissions are coming from industrial processes that are well below that. Next slide, please. So here's that, again, that long tail, things like glass and some metal fabrications, very high heat, but a lot of, again, lower heat processes. Next slide. So if we add that up across the United States, in fact, we find that about almost 80% of industrial heat is happening at medium or low temperatures. And that really only about 22% of industrial process requires high heat in the US. So that was a little bit of an eye-opener for us. And what it started to get us to thinking is that some of the technology solutions required to decarbonize industry might be available now, or might be not what is often assumed there to be, meaning we can look for things like heat pumps, solar thermal, storage. We don't have to wait for hydrogen or other high heat solutions, but rather we can get to work more quickly. Next slide. So we looked at a whole suite of available thermal technologies. We go into sort of how we narrowed that down in the report. If we go, so these are the whole suite. Going to the next slide, we narrowed that down. If you go to the next slide, and then looked at the those 6 key technologies on the left, sectors on the left. These were all the checks were the ones that were applicable. So in other words, you could use green hydrogen, which has a primary temperature of 2100 degrees for the food industry, but you really only needed to get to 130 degrees. So it's not the primary. You wouldn't choose green hydrogen because it's not as efficient. So then we identified in green the ones where you might be a little bit more efficient. And so that might be a better option. So with that in mind, we identified technologies that were more well suited for particular sectors and more efficient. Next slide. Next, we looked at some cost assessments and compared those to natural gas reference cost. So if you look to the far right here, you see the natural gas reference cost. So this would be a range given different states with the dashed line indicating the cost range with the levelized cost here on the left. You can also see what the cost would be with CCS for natural gas. And then we compared it to some of those key technologies: green hydrogen, RNG, electrical resistance, those in pink indicating that they could be used for high temperature applications, thermal storage, waste biomass, solar thermal, indicating medium temperatures, with even can get ratcheted up to higher temperatures, and then heat pumps down at low temperature. We also updated this and modeled in the effects, including the IRA subsidies. So you can see the huge impact that has on green hydrogen, taking it down from $40 way down below 20 and putting it in a competitive range. That's with the production cost reduction doesn't maybe fully account for all of the cost to switch. So what it shows you is that as of this analysis, you have a lot of potential technologies within the range of competitive in a range of potential geographies with natural gas. Next slide. And based on that, we sort of created this stack then for how these different technologies could be used to decarbonize industry over time in the relationship that they may have. So this is pretty dense. If we go to the next slide, it shows the same thing with more of a visual stack chart. So with natural gas being phased out at the top, biofuels in the red, petroleum, coal being phased out completely, waste biomass. So this takes you through an aggregate of all of those sectors, their current fuels over time. What this was built based off of was a series of the specific sector stack charts and analyses. And I'm going to go into those very quickly in my last minute or so, just to give you an example of what those look like, so that when you go and download the report, you kind of are oriented to those. So can you jump ahead a slide? Next slide. Next slide. Okay, so we'll go to the next one. So this is just a quick breakdown that shows you where all those emissions are by state. So the industrial whole, for these 6 sectors broken down by state, this is where they are geographically. Next slide. So for, why don't we go, we'll stay here. So for the food industry, for example, this is that stack chart for the food industry. So you have starting in 2021 on the left, going to the mid century, you have huge opportunities for electrification in purple growing. You have opportunities for solar thermal picking up. You have a continued use of waste biomass, also eventually phasing out. You have RNG playing a big part initially in the near term. And then you have natural gas, which is predominant now, eventually phasing out. This is obviously this particular sector. The big story here is electrification. And then on the right side, you can see the emissions basically phasing out significantly based on that phase out of natural gas. Next slide. The thing that I want you to note is that then there's also insights based on where those emissions are by sector in the report. So you can take a look at the specific sector, say the food, and how they relate by state. And then next slide. And then there's some more specific slides that relate to this, but and build this up. But then there's basically some recommendations about which technologies by sector, by geography, and like in this case, some insights into why heat pumps would make sense in a particular state, why, for example, solar thermal costs in a particular state, and then therefore what some recommendations may be as a starting point. So again, the purpose here is which technologies to start exploring in which sectors and which geographies, and so that's the idea there. And then so there's the slide deck, which there's a little bit more in this slide deck, which we'll skip through for time's sake. But then at that link, which I shared, is the full report, which you can download all 200, or you'll see when you go in there, you can look by sector, you can look by technology. So why don't I pause there? And then, yeah, Jasmine, you just skip through to the next section. So the cement, you can see, and right there. And then Ruth,
Okay.
over to you. Thanks.
Great. Can you all hear me? I'm calling in, but you can also see my face.
Yes, I can hear you.
Yes.
Okay, perfect. Well, thanks for having me today. I'm excited to be walking through our findings in a little bit more detail on industrial electrification in U.S. states. Dan gave a great overview of the vision report, which has a lot of detail across the technologies that the RTC looks at, and given the key findings on low and medium temperature heat and industrial electrification as a technology that can help to decarbonize those applications, we're able to do a lot more work in this area and look at it as a high value technology solution. A bit of background on me: I am a project and research director at David Gardner and Associates, which is one of the three co-conveners of the RTC. So if you'll go to the next slide. So this report is a follow-on to a report called Electrifying U.S. Industry that Global Efficiency Intelligence and David Gardner and Associates partnered on in the past on behalf of the Renewable Thermal Collaborative, that had a overall federal level view of technologies for electrification across the U.S. And then this report goes into much greater detail on 20 U.S. states. So there's the report, which is about 80 pages long, lots of graphs included, and then individual state fact sheets, which go through findings for each of the states listed here. So on the next slide, I can give a bit more detail about how the states were selected and which ones were included. So on the left side here, you can see a map of the greatest industrial energy use in 2019, evidently Texas, Louisiana, but then other states like Illinois, Indiana, Ohio, Pennsylvania, and California use a lot of energy in the industrial sector. And so this study included 18 of the highest industrial energy use states, and then 2 states that were more forward-looking in energy policies, and that's why they were included. And then on the right side, the study really looks at how energy costs, energy savings, and emissions reductions will be impacted as a result of electrification. And so key to that is the ratio of electricity to natural gas prices. In 2021, you can see the US average was around 4.5. So electricity 4.5 times the price of natural gas on average across US states. But there are a number of states where it's below that number. So in those states, electrification is more attractive. And then also not pictured here, the study looks at the grid emissions factor in each state in order to be able to understand whether there needs to be more clean electricity on the grid before electrification will produce CO2 emissions reductions, or whether it's ready now. So on the next slide, you can see 12 sectors that we looked at. It's a mix of heavy and lighter industry. And today I'm going to give a bit of an overview of what we found in the container glass industry. So next slide, please. Here you can see energy savings depicted across the states we analyzed in 2030, 2040, and 2050. The container glass industry switching from conventional fuels to electrification produces significant energy savings. So the graph is shown in negative numbers to indicate savings in terms of total final energy use. And you can see that that's greatest in states like California, Indiana, and Illinois. Then the next slide has a map of emissions reductions. And not surprisingly, the states with the greatest energy savings also see the most significant emissions reductions as a result of switching to electrified processes. So California and Indiana here. And this is showing in 2050, but the report also goes through findings in 2030 and 2040. So you can see how over time, as the grid in each state is getting cleaner and cleaner, according to a variety of scenarios and projections, how that will impact the emissions reductions that the switching to electrified processes could produce. And then the next slide is focused on cost. So right now, with current electricity price forecasts, we can see that conventional processes are less expensive than electrified processes. However, the yellow and green bars on this graph, which I recognize is a bit busy, so just you have to focus in a little bit. And those show that with lower renewable electricity prices, it's more cost competitive to switch to electrified processes than it is to stick with conventional processes on a per unit of production basis. It's also important to note here that for many of these industrial subsectors, the energy cost is really only a small portion of the total manufacturing cost. And so the downstream impacts of a slight increase as a result of electrification may not actually impact consumers or final product prices quite as much. Then on the next slide, taking a step back from findings for the container glass industry and looking across the 12 sectors studied in this report, with the exception of a few that are a bit less direct to electrify, we can see the total energy savings with a 100% adoption rate in these industries, and we're seeing significant energy savings across these states. Some obviously have more savings than others as a result of having more industry, or the sectors that were studied are more prevalent in those states. But these are really significant savings in total final energy use. And so the efficiency increases here are key to also producing CO2 emissions reductions. So on the next slide, we can see those. This depicts emissions reductions across, again, the same 9 industries studied in 2030, 2040, and 2050. Indiana has significant emissions reductions from electrification. Ohio, Illinois, Pennsylvania, and Michigan are not too far behind. Interesting to point out here, certain states in 2030, because of the grid emissions factor, so the level of CO2 emissions on the grid is not low enough to produce CO2 emissions reductions with electrification in 2030, but as the grid gets cleaner, we expect those to fall below zero, thus producing decarbonization. And then on the next slide, please, this is looking at electricity demand impacts. So as we electrify, although total final energy use decreases, electricity demand overall increases. And this is key for utilities and regulators and state energy officials to understand as plans are made to increase capacity on the grid, and we look to be able to meet the demand that industry requires over time. So you can see here, again, Indiana is leading in all of these graphs for the sectors analyzed in this study. But the Vision report also has really good insight on electrification and which states are ready for it now and which states will be ready for it before 2035. So on the next slide, we can get into a few takeaways. Sorry, I think we went one more forward, please. And again. Ooh, I think we are moving backwards. Apologies. Well, yeah, here, great, thank you. So there's state fact sheets. This one shows Indiana because of Indiana's significant energy savings and emissions reductions, as well as electricity demand increases. I thought it would be great to show. This data is pulled from the EPA's flight database and has really interesting facility level data, but it shows the sectors with the greatest potential for emissions reductions from electrification in 2050 in Indiana are the steel, soybean oil, and wet corn milling industries. And then on the next slide, I've pulled out findings for Pennsylvania as well. But you can access your state fact sheet if you're curious to see this sort of map and specific recommendations by industry online, and I'll put the link in the chat after this. And then some takeaways, if you'll go to the next slide, please. We've already talked on all of these, but there's clearly significant potential to decarbonize U.S. industry with electrification. In many states, grid emission factors are low enough that CO2 emissions reductions can be achieved today, and that is true of more states in 2030. But we can also see plant level emissions reductions right now if there's sufficient renewable electricity supplied through a power purchase agreement or other type of behind the meter supply. The energy cost is a significant barrier to electrification. However, as renewable electricity becomes more available and low prices are more ubiquitous, we can see that change in the economics become more favorable for electrification. And then there are also many co-benefits, including air pollution reduction, and then also certain production cost reductions. And so on the next slide, and I want to get moving towards Chris's more specific insight on policy. The key message for this is that we can start electrifying now. States with cleaner grids or relatively lower electricity prices, it's more attractive. Partnerships between government and industry can help move along to develop and scale electrification. And those demonstration projects are really key to make it more available and develop the market forward. And so these 6 recommendations are fairly high level, but as the RTC continues to work through policies and other market initiatives, we plan to get more granular on this and would love to work with state energy officials to make these really applicable to each state. So thank you for your time. I'll pass it over to Chris Kardish now to talk about policy.
Thanks, Ruth, and thanks, NASEO. I'm Chris Kardish. I'm the Senior Manager of Industrial Decarbonization at C2ES. We're the 3rd co-convener of the RTC. I lost my voice over the weekend, so bear with me. I'll try to deliver this quickly so we can maybe get to some questions if there are any. You can go ahead and take it to the next slide, please. So yeah, I'm going to dive a little bit into how we're thinking about policy, what we're exploring these days. And just as a starting point, it's useful to think about the specific technologies that have our attention at the moment on electrification. And that's certainly industrial heat pumps, thermal energy storage, and other electrical resistance technologies. And Dan's already alluding to that a lot, but in the case of IHPs, we're seeing a very promising technology, the low temperature applications at very high efficiency that makes it cost effective, potentially with natural gas in a lot of places today. Thermal energy storage is a newer technology, but very intriguing in that it can capture renewable power at lowest cost times of day to deliver direct heat or heat for long duration storage using a variety of different storage mediums, many of them using common solid materials and at high temperature ranges, even extremely high temperature ranges, as well as providing steam at lower temperature ranges. And then with electrical resistance technologies, electric boilers particularly come to mind in sectors like food and beverage, in part because they're higher efficiency than natural gas boilers and potential for emission savings where depending on the electricity source. You can go to the next slide, please. Our sense of the Inflation Reduction Act sort of at root is that, of course, it's a huge leap for US climate policy and in supporting industrial electrification by greening the grid broadly, but that there are some significant gaps. First of all, just in particular, there's little to incentivize electrification of industrial end uses. So for instance, there's very little in the Section 48 investment tax credit in terms of electrification technologies. The new Section 45X advanced manufacturing credit, which helps to build domestic supply chains of key technologies, largely neglects electrification technologies. And there are while there's some opportunities to do electrification through the 48C Advanced Manufacturing Credit and the DOE Advanced Industrial Facilities Deployment Program, both of these are limited in their overall funding and, of course, have pretty wide mandates and will be quite competitive. They're not just doing electrification. You can go to the next one for me, please. And so the state level somewhat mirrors this in that there are limited policies that directly target industrial end use electrification, but there are certainly policies to support on-site deployment of renewables. State governments, of course, are more constrained in terms of their level of financial support, which leads to more limited use of tax incentives, which at the state level are usually more targeted toward, their state and local purview. So things like property taxes and sales and use tax exemptions. You can go to the next slide for me. We have a deeper understanding of what's happening at the state level, in part because of this tool that we developed and released this year called the RTC Policy Finder, which is available on our website. It provides a breakdown of policies that are relevant to renewable thermal across technology and fuel areas, and then across different policy types, across all 50 states and soon federal policies as well. You can go to the next slide for me. And so drawing from the policy finder, specifically looking at electrification, there are definitely some trends that we pick out. So across sort of the main policy types in the tool. So in terms of grants and then research development and demonstration, as I kind of hinted at before, we see that grants are often usually more limited in terms of direct support at industrial facilities for electrification, though there are examples in New York, Maine, and Colorado. Often this sort of support is more focused on RD&D for novel technologies, but we see those kinds of programs across blue and red states. In terms of regulatory policies, these are often more indirectly supporting industrial electrification, as is the case with portfolio standards. But of course, we do occasionally see carbon pricing or similar measures at the state level in some places. In the case of sustainable finance, there are numerous prominent examples of green banks and then clean energy funds that are aimed at providing bridge finance. Even more commonly, though, we see loans and bonds that are focused on electrification related investments, particularly supporting on-site deployment of renewables and across blue and red states. Then lastly, as I hinted, tax incentives are often targeted more at property tax and sales and use tax exemptions or abatements. Though we do see examples of credits, including in states like red states like Florida and Utah. You can go to the last slide, I believe is my next one. So when thinking about the policies that we're really exploring right now, they tend to fall into a number of buckets. So first is expanding tax incentives federally to both build domestic supply chains and support deployment among end users. And that can be done through a number of levers, including adding industrial heat pumps and thermal storage explicitly to the 45X credit, using the 48 ITC and other ways to sort of address additional costs that end users face in deploying these technologies. We think the demonstrations are very much needed, including on heat pumps domestically, specifically US demonstrations, because this is needed to help decision makers in companies effectively sort of de-risk these investments and have a track record on which they're basing decisions. We also recognize that we're going to need to look at barriers that are sort of in electricity markets themselves, particularly regarding thermal storage, which will require engagement with FERC and then RTOs and ISOs. Somewhat related will be likely needs for state level work, trying to expand and enhance performance-based rate making for utilities to allow for more competitive pricing structures as companies rapidly increase their electrical load Then lastly, we recognize there's going to be some need on workforce development for key electrification technologies, including heat pumps, because we don't really have the fully adequate workforce to service and deploy these technologies currently. That was quite fast, but I don't know that we have a ton of time for questions.
Thank you. That's a lot of stuff. This is very impressive, and it'll take a little while to digest. I guess maybe I'll start off with a question, Chris, on policy, and maybe this extends to the others too, as far as incentives. Is part of the impediment also depreciation rates and lack of incentives for turning over capital? I mean, if I'm a business and I have my existing boiler or furnace and it's working okay and I repair it, it's I can expense that. Whereas if I'm buying a whole new device, that's a capital expenditure, which gets into finance and tax issues.
It's a very good question. I can quickly lead it off, and I think Blaine might have more to say. I think that's certainly a valid issue, capital turnover. I think what we hear a lot, though, from companies is not even necessarily the capital investment. It's all the other process changes that are required for electrification, including upgrades of electrical infrastructure, but also sometimes turning over whole processes, for instance, from sort of steam-based centralized processes that distribute the steam across the facility to, say, hot water-based heat pumps. And then, of course, being tied to electricity prices and sort of being asked to forecast those out over the long term, hesitancy over that relative to natural gas prices. But the capital turnover thing is definitely valid. I don't know if anyone else wants to jump in there as well.
The only thing I would add is that no one's going to CapEx their way out of this, right? No one's going to CapEx their way to net zero. One of the incredibly important lessons from the electricity space is the willingness of third-party capital to come to these issues, as long as we can instrumentize and commoditize to dial in our understanding of the economics and the risks, right? And there is third-party money coming to this space, and a lot of it, and that's really quite exciting.
So maybe following up on sort of the issue, Chris, that you had mentioned about de-risking and your response to the last question, are there industries which may be more conducive to doing a demonstration on part of the facility? You know, thinking about if I have my production facility, I'm less willing to disrupt my entire facility to try this new device, rather than can I try it on one line or a portion of my facility and see if it works.
It's a very good question. I don't know if any of the others have a good specific industry in mind. I have sort of non-examples where the processes are sort of especially entwined and very challenging. And I probably have more non-examples than very good examples where that's not the case. I don't know if I think so. Chemicals, for instance, I think that might be a particularly challenging draw. I don't know if, say, food processing, there's less of a concern on that front.
I was going to say there's some food sector work is seasonal or has, ebbs and flows depending on the season or the demand cycle. So that could be something to think about, is how to cycle it in during the natural down cycle.
And let me pause to see if anyone in the audience has additional questions. So you've sort of answered another question that had come up before, which is, what are the main barriers from buyer's perspective for industrial electrification? And I don't know if there's anything more to add beyond your response already, but I'll invite you to do so if you wish.
Unfortunately, I have to join the same call that Blaine has to join.
Oh, okay.
I'm sorry. But I don't know if Ruth and Dan can stay. But I'm sorry, I have to join the same call.
Okay.
Sorry. Thank you so much, everyone.
Yeah, thank you. Ruth, Dan, anything more to add? And if not, we can close out soon.
I think I'm unmuted. Okay, great. Quickly, just to add, I think the buyer perspective is really often focused on the costs and the long-term costs. So not just the CapEx, which my colleague said earlier, but also the long-term operating expense. And then just navigating the tactical issues of process integration. You noted whether or not you have to turn off an entire system in order to bring in technology. And so figuring that out for a specific process can also be challenging. And then aside from that, matching temperature requirements to the right technology is something that the RTC is trying to provide tools to support on. We have heat pump decision tools, as you can see on the slides here, for heat pumps, but sometimes there might be insufficient supply, like the US domestic heat pump market is pretty nascent. And so that can also be a barrier to getting the right technology.
Dan, anything to add?
No, just the only thing I would add is that we're finding, as we're looking at trying to see how to help scale up the deployment of heat pumps, in particular the industrial heat pump in the US, is that there's a whole set of issues that all need to be dealt with at once in order to sort of accelerate that. There's no heat pumps available on the market, and so we're talking to the manufacturers, and they're saying, well, there's no demand signal. We're talking to the utilities, and they're trying to figure out how are they going to balance the increased local loads with the sub at the local level, at the substation. How are they going to pay for that? How are they going to price that? And so it's like the whole ecosystem right now of all the little things that need to be done from all of the different stakeholders, which would sort of naturally be worked out. It's what everybody does in this market. All have to be figured out. And what we're trying to figure out is how can we come in and sort of get the right people in the room, talking to each other, building trust to sort of accelerate that. So instead of saying, okay, yeah, that'll all get figured out in 5 years, it's how do we get it done in 18 months? Instead of having the production lines for 3 years from now, how do we get it so we can do pilots and so that we can start taking delivery of heat pumps next year? How can we get it so that the utilities are offering special pricing or performance-based rates next year instead of 3 years from now? So different things like that. It's just that idea of, we know from all the reports and everything we talk about that it's the right option, but it's down the road. So how do we work to accelerate that? And it's not just a single tax incentive or just awareness raising. It's the 10 little things that need to be done, trying to get the right people to sort of coordinate and talk to each other and be in the same room so they all can look each other in the eye and say, all right, let's do this thing together, and try to accelerate that progress. So that's kind of where we're focused right now.
Okay, great.
Comment here too about that in the chat for everybody.
And I'm looking at Melissa Stewart's comment there too. So good. So we are beyond time. So, but I do want to also mention that we have a grid interactive efficient buildings working group too. And you're bringing up electric distribution planning and performance-based regulation is also appropriate to that group. So I think we should continue the discussions with respect to this working group, but also thinking about demand flexibility and distribution systems and how that can or is maybe not so well suited for electrification. So with that, and many thanks to Melissa for adding her comments. And I see there's other comments. Many thanks to all of you. Appreciate your participation. And many thanks to the RTC partners and friends there. And we look forward to working with you more as we move forward. And everyone, have a good rest of the afternoon and good week. Take care, everyone.
Yes, thanks, everyone.
Thank you. Take care.